Okay, we'll continue on with solving a system of equations. This is video 2. We'll be looking at solving a system of equations using elimination, also called the addition method. So our objective is to be able to solve a system of equation using elimination. You can solve system of equations with elimination. With elimination, you get rid of one of the variables by adding. I'll just keep to adding. I don't worry about subtracting. That gets too confusing. You may have to multiply one or both equations by a number to create variable terms that can be eliminated. In its very simplest form, you want to get rid of one of the variables, okay, by adding. In order to do that, they have to have the same coefficient but be opposite in sign. So for example, if I have a 2x and a negative 2x, they're the same coefficient 2, the number in front of the variable, but opposite in sign. One is positive and one is negative. When I add them, I'll get 0. What happens if I had 2x and then 2x? Well, when I add those, I would get 4x. I want 0. So what I would have to do, I can multiply either one of these by negative 1. And I would get negative 2x and then 2x. And so then when I add, I get 0. Okay. So you may have to multiply one or both of the equations by a number to create a variable that can be eliminated. Let's take a look at some more examples. Let's say here I had negative 4x and a 5x. Okay. The coefficients are different, but the signs are opposite, so that's good. I have a negative 4 and a positive 5. All right. I want to have the same coefficient, but opposite in sign. So what can I do? I can multiply negative 4x by 5. That's a coefficient for the one below. And I can multiply 5x by 4. That's a coefficient for the one above. So now I'll have negative 20x and then 20x. And so when I add, I'll get 0. I'll get 0. And then finally, maybe one more. What happens if I had 7, make it easy, 3x, and then 4x. So what would I need to do? Okay. Well, what I could do, notice that the coefficients are different, 3 and 4, and the signs are the same. Okay. They're both positive. So what I can do, I can multiply the first equation, the first one, 3x, by the coefficient of the other one, 4. And then I can multiply the other one, 4x, by the coefficient of 3, but we need to make that a negative 3 because remember, when we add, they have to be opposite in sign. So here we have 12x, and then negative 12x, and when we add, we get 0. So that's the background in using elimination. Important point, the elimination method is sometimes called the addition method. Important point, though, is that you want one of the variables to have the same coefficient, but opposite in sign. I did these, same coefficient, opposite in sign, same coefficient, opposite in sign, same coefficient, opposite in sign, same coefficient, and the coefficient is the number in front of the variable. So let's look at some examples here. Use elimination to solve the system of equations. Okay, we start off pretty easy. Notice here, I can easily eliminate the y's because the coefficients are the same and they're opposite in sign. So we just add. 3x plus 4x is 7x. That gets eliminated, and 4 plus a negative 18 gives you negative 14. You divide by 7, you get x is equal to negative 2. Okay, so now this is like substitution. So all we have to do is take x is equal to negative 2, and we can actually substitute it into either of those equations. It does not matter which one. Okay, I'll just choose the first one. We know that x is equal to negative 2, so 3 times negative 2 plus 2y equals 4. Negative 6 plus 2y equals 4. Add 6, you get 2y equals 10. Divided by 2, you get y is equal to 5. So we have solution negative 2 and 5. And we can check. So we can check. I'll check. Okay, so I'll just use equation 1 and equation 2. So 3 times negative 2 plus 2 times 5. And that's negative 6 plus 10. And that's 4, and yes, that equals 4. So it checks out. I was working with equation number 1 here. number 1. And then I can work with equation number 2 to check. So again, x is negative 2. So 4 times negative 2 minus 2 times 5 equals negative 18. Let's see here if that works out. We have negative 8 minus 10. Yes, negative 18 equals negative 18. That checks out. Okay, so it works. Elimination. Elimination, and then we go into substitution. So let's see here. So here, notice here, so the coefficients are either x or y. I mean, they're different, and they're all positive. So we have a choice here. We can eliminate the x's, or we can eliminate the y's, whichever one you want to do. They chose to eliminate the x's. So what did they do? They multiplied the top equation by 2, and then you multiply the bottom equation by negative 3. And so you have to distribute. Okay, so notice here. So, all right, so 2 times 3x is 6x, and 2 times 5y is 10y, and then 2 times negative 16 is negative 32. Again, you have to multiply each term by 2. And then for the bottom equation, you multiply, so the bottom equation here, they multiply negative 3 times 2x plus 3, so they got negative 6x minus 9y, and negative 3 times negative 9 is 27, and then you add. So when you add, you eliminate the x's. You get y is equal to negative 5. So now this is like from step 3 of substitution. Now you take what y is, and you substitute it into either one of the equations, 1 or 2, it does not matter. 1 or 2, it doesn't matter. So here, which one seems easier, I'll just choose the first one. So 3x plus 5 times y, which is negative 5, equals negative 16. So 3x minus 25 equals negative 16. So 3x equals negative 16 plus 25, and what would that be? 9. Right? 25 minus 16 is 9, and so divide by 3, and x equals 3. So solution, 3 and negative 5. X is 3 and y is negative 5. Then we could check. And then finally, let's look at one more of these here. So again, so this is nice because we have the same coefficient for y, and they're opposite in sign, so we just add. 4x plus a negative 12x gives us negative 8x, and then negative 25 plus 19 gives us negative 6, and you divide by negative 8, you get x is equal to 6/8, or 3/4. 3/4. That's what x is equal to. And so what I can do is I can take that 3/4 and I can just substitute it into either equation. So I'll substitute it into the first equation. So I have 4 times 3/4 plus 7y equals negative 25. 4 times 3/4, you cancel out the 4's, and you just get 3 plus 7y equals negative 25. Subtract 3, you get 7y equals negative 28. Divide by 7, you get y is equal to negative 4. Solution, 3/4 and negative 4. 3/4 and negative 4. I think elimination is easier sometimes. All right, so there is elimination there for you. Okay, so you'll have some problems to do using elimination.